Yes, looks like we're live.
And in the right channel and the right
Yes,
event.
I think
Perfect.
so.
Hi guys, if you can see us, if you can hear us, give us a heads up, leave us a comment, let us know if it's going okay.
Vasily is already here.
Perfect.
Greetings to our JetBrains friends.
And Johan is also live. He says that you said 25 minutes ago. We'll be live in a few minutes.
Uh-oh.
Cool. Amazing. We figured it out.
Wolfgang
Great.
is here. Johan made it. Francis made it. Sachin is here. Hello.
Yeah, today we are actually streaming in a different time from our usual time because this is a very busy week for us. Some of us have been at Java One and Vox Zurich, and some of us will be going to Vasmayo. So we had to adjust our normal streaming time. But it actually might be a good thing because I think this is a very friendly for EMEA time zone. And I think even for folks in India, this is still an acceptable time to join. So I'm very excited. Maybe we will have some more people joining this time from other areas. So also you can let us know in the comments where you are joining us from and if this time works for you well. Okay, I see people are joining. Should we slowly start because we have a tight deadline today, right? And we have a lot of things to cover. So should we probably slowly
Yes,
start?
let's go.
Okay. Okay. I think my screen should still be somewhere here.
Let me pull it for you.
Perfect. Thank you so much. Okay, so hi again, everyone. We are here today to talk with you about GraalVM for JDK 24 that went live last week. So maybe you had a chance to actually try it and you will be able to give us your feedback and ask questions specifically about this release. And my name is Alina. I'm a developer advocate for GraalVM at Oracle Labs.
And I'm Fabio Niparas. I'm a researcher on the GraalVM team, and I'm also very excited to be here and talk about GraalVM and Graal languages.
So am I. Let's go. So we will do it in a similar format like we did last time, where first we will talk about JDK and native image. And you might have noticed that now we have two release blog posts coming at the same time. One is about JDK and native image, and the other one is about Graal languages. So in this hour today, we will try to fit all the info about both kind of big releases, JDK native image and Graal languages into this 1 hour. So stay tuned, and we love feedback. So whatever comments you have, questions, if you love some feature in particular, let us know in the comments. We love hearing comments like that. With that, let me open the first release blog post so we can talk about it in more detail. So last week, as you might know, we have released GraalVM for JDK 24, and it's very easy to remember when we have releases. We now have the exact same release schedule as Java, so twice a year, every 6 months. And in March and in September, you can expect a new Java release, and on the exact same day, you get a new GraalVM release. So if you want to get the latest Java version, as you should, may I suggest that you just get the latest GraalVM build, and this way you can use both the latest Java and GraalVM features with one JDK installation. So it's already live and available. It's available on all the platforms. You can grab the download from GraalVM.org, our website, or if we may suggest, you can use SDK Man, which is our favorite tool to manage JDK installations, and you can get GraalVM from SDK Man. Let's see what's in this release. If by any chance you already had a chance to read the release blog post or the release notes, you can let us know what is the main interesting feature for you in this release. And I'm going to start with talking about how we are using machine learning in native image to give your native executables even more performance. So you might know about something that we have in native image that we use a code name MLPGO for. And that is our way of using machine learning to infer the profiles of your application and then optimize as we build your application for that specific inferred behavior to give you more peak throughput. You might also know that we have user-provided PGO, like a normal PGO, where you need to do kind of a trial or a training run and run an instrumented version of your application to collect profiles so that we can build a native executable that is aware of those profiles and can give you even better high performance. But in case you don't want to do this two-step process, even though it is recommended if you want to have really the best possible peak performance with native image, what we can do instead, you would think that maybe we can use something like ML to try and predict that runtime behavior of your application, and indeed we are doing so. So this is actually not a brand new feature. We had ML PGO for native image for about 2 years now, but in this release we are introducing GraalVM, which is a new generation of this ML-based profile inference. And with that, we are very happy to see peak performance improvement of 7.9, almost 8% out of the box on a wide range of applications that we are using for benchmarking. And in particular, this applies to microservices workloads. So we run a lot of Micronaut, Spring, Quarkus, Helidon benchmarks. And on average, we observe that with this new optimization, we see almost 8% peak performance improvement over the baseline, which is not having any profiles at all. And I think this is very nice to be able to have 8% better performance just out of the box with one build. And as an illustration to that, there's this one particular benchmark that we picked up to feature in the release blog post. And this is a Micronaut application running with ML-enabled PGO in GraalVM for JDK 24 versus running on the baseline configuration, so with no profiles in place. And we are measuring peak throughput in operations per second. And you can see here that in this example, we have 10.7K requests per second versus 11.6. So almost 1K more operations per second on this application, which again, I think is a very nice win that you can have out of the box without having to do any additional steps as a developer. And it gets better. We have a paper published about this work if you want to learn more, but also we are preparing even more excited updates in the next release in autumn in GraalVM for JDK 25. And there we will have a context-aware version of this optimization. And we believe that we can get even better peak performance out of the box with this optimization in GraalVM for JDK 25. So you always ask us for more peak performance in native image out of the box, and we delivered. I'm personally very excited about this one. So let us know what you think. And I don't know, Fabio, you maybe have some comments about this too.
Yeah, the only thing, and that's also mentioned in the blog post, is that right now, if you want to use this, you need to use the -03
Yes.
option, which essentially means maximize for performance. And that allows us to use a bit more time doing compilation, but also doing the static analysis to optimize your application for performance. So by default, you're not using the Graal GNN, you use the previous version, which is still pretty good. But if you want to get like the last 10%, last 5% in terms of performance, you really want to build with -03. You also get -03 when you do user-provided PGO builds.
Yeah, thank you. That's an excellent point. And you made a good point about the previous generation. So for the previous generation, again, the exact speed up will depend on your workload. But on average, it's safe to say that with the previous generation, you could expect it somewhere around 6 to 8% performance improvement. And now it's strictly 8% on average. And we can get even more in GraalVM for JDK 25. So I think this is excellent. And we can move on to the next topic. And I think I can see in the chat that other people are also excited about this optimization. Yeah, I think it's very cool. It's great to see the magic of ML making this possible, but also the great work of our native image team paying off. Okay. And the next topic here is even smaller native executables. So it starts to look at me like the theme of this release is like better, faster, stronger. So all around better native executables. And indeed, another thing that we have added in this release is this new SkipFlow, which is an extension and optimization to our points to analysis. So this analysis in native image is that step where native image goes through your executables, through your project, and it's trying to find the code that is reachable to analyze your application to understand what needs to end up in this final produced native executable. And now with SkipFlow, it is possible for us to produce smaller binaries. And on the chart here, we can see how smaller exactly on this, again, wide range of benchmarks, but on average, with this optimization enabled, you can expect about 6.35% smaller native executables if you enable this optimization by passing a flag. Now, what I wanted to add about this, if you are wondering about the build times, there are also good news. This does not affect build times in any bad way. If anything, it makes build times smaller, slightly shorter, because there is less for us to analyze. And if you want to give it a try, it's in this release, it's experimental, but we plan to make it enabled by default in the next release. If you do want to try, you can pass those two flags to give it a try on your workload. And we were actually very curious to get your feedback to see how it works for you, so we can further improve it into the next release if needed, because that's when we plan to make it on by default. So smaller native executables is, again, something that often we hear from our community. It would be nice to have. A couple of releases ago, we introduced -OS, which is a specific optimization level in the compiler to make the smallest possible native executable. But if you want to maybe have your default settings, maybe you want to optimize for peak performance, with this optimization, you can get still slightly smaller native executables.
Yeah, and in case you're wondering how this works, static analysis typically needs to over-approximate what's reachable in your application. It cannot know for sure what toString methods, for example, are always needed, so it includes them all, right? But in this SkipFlow project, the team has worked on improvements for the static analysis that can essentially track primitive values, and it can evaluate branch conditions, essentially improving the precision of the analysis and making sure that certain methods that you really don't need are also removed. So essentially, like reducing the overestimation in the analysis, and that's how we can get these nice file size improvements.
Thank you, Fabio. And another thing that I know was highly anticipated by our community is extended support for Java agents in native image. This has been a big kind of discussion topic in our community for a while. We have a GitHub ticket where we go back and forth with our community about how to make it happen. And then in this release, we are introducing some nice new changes. So in general, agent support in native image has been this topic discussed so much because for a while, people thought that they cannot use Java agents in native image, which is not true. You could have been using Java agents in native image even until now, but there are some restrictions that you needed to be aware of. So you needed to be using the agents at build time. You had to be very careful for the agents to not interact with the classes that are being used by native image. And then we needed all the classes from the agents to be available to us as we are building your native executable. So most of the work related to the agents was happening at build time, but normally you want to be able to use the agents at runtime. And in this release, we are making a first step towards that support of agents at runtime by introducing support for pre-main of the agents at runtime. And we also want to thank here Alibaba, who have made the contributions and helped us make this happen. So the way this works at the current moment, and we will have more support coming in the upcoming releases. So at the moment, you would need to use this pre-main classes flag as you are compiling your application. And then when you are running it, you will again need to use another flag to set the runtime options. So I think this should be very exciting for our community. I know several people for sure who will appreciate this update. And this is, again, another point where we want to ask for your feedback, and namely, which agents specifically you would like to use with native image so that we can look in that direction and maybe collaborate with the agent teams to make it possible and make it happen for native image. So give it a try as is, but also go to the GitHub ticket that we are linking here and let us know which agents specifically you want to use with native image. Now, in other updates, this one is something that I'm particularly super excited about. We are extending support for Vector API in native image. Now, this was, again, available for a while, but then in this release, we have extended how much of the Vector API we're currently supporting in native image. And while it is still experimental, we have added a lot of optimizations in this release. And the reason why I'm so excited about it is that there are many applications that can leverage Vector API to speed up the workloads. But namely, the class of applications that makes this so exciting for me is that you can run multiple kind of LLM applications with this. And namely, you might know that there is this Llama 3.java project from our colleague Alfonso Patterson that is an LLM inference engine built purely in Java. So by using this project from Alfonso, by pulling a model, you can have your fully local little LLM assistant running on your machine, just purely on CPU. And the reason it is, the way it's implemented is we are using the FFM API from Java to work with that model file and to make that native access. And then we are using Vector API to make that application very fast. So I think this project is a great showcase of how the latest Java APIs make possible to even implement things like LLM engines just in pure Java. You don't need Python, you don't need native extensions. Even though they are amazing, we can implement all of it in Java. And then with Vector API and specific optimizations in GraalVM, we make them very fast. In fact, we don't talk about it here, but we did some kind of benchmarking, and we see that with GraalVM, and namely with Oracle GraalVM, you can run such workloads even 20% faster, because our Vector API support, while being still experimental, it is actually very good. So we are very excited about this, and later on, if we have time, and I think we'll try to find time, I will try to show you a demo of this project going live. But this is super exciting, and yeah, great to have support for latest Java APIs in native image. Now, moving on with other updates in this release. So we often talk about how native image is great for startup times, for memory usage, for smaller packaging size, but native image is great for running Java more efficiently overall. And one new area where we see a lot of interest in native image from our community and our users is using native image as a way to run Java applications in a more green manner, such as using less energy, using less electricity. And this comes from the fact that native image, by compiling your application and optimizing it ahead of time, can use significantly less resources when it actually runs your application, because there is way less work for it to do, as opposed to the JVM that needs every time to warm up, to look at your application, understand what it does, load classes, compile, etc. And as an example here, we added a new benchmark to our benchmark suite, where we are running Spring Path Clinic, and we are measuring the energy consumption of running that application on the JVM and with native image. And here we are measuring how much energy it takes in different scenarios, such as just starting that application and getting one request back, up until the way where we are hitting the application with constant high load. And that we see then on the left, that kind of green chart, that is the JVM energy consumption, and the orange one, that is the native image. And we can see that even under high load, when the application is properly warmed up, native image still consumes, I would say, roughly 30% less energy, just because it is more efficient. There is less work to do for native image, and there is less kind of runtime overhead in the case of native image. So I know for sure that this is a very interesting part of native image. I know that there are several people doing talks and writing blog posts about green Java and green tech, and they will be excited to use those numbers in their content. Now, another interesting part for native image, and I like this because I think this is a very kind of production-grade, production-beneficial feature of native image, is that in this release, we are extending our SBOM support. So again, we had SBOM support in native image for a while, but in this release, we have added several new features, and this is a great work done by our security team, and namely Joel, who contributed to this a lot, and we are very grateful for this. So in general, it is always possible to build a native image that includes SBOM with this enabled SBOM flag. But what's new in this release, if you want to have even more accurate SBOM, and if your project happens to be a Maven project, we recommend that you use our native Maven plugin. So the Maven plugin coming from the native build tools developed by our team. And in that case, if you're using it, we are able to use under the hood this Cyclone DX Maven plugin to produce even more accurate SBOMs and better map the classes that we see in the application to the SBOM components, and have a better understanding of what goes where and what contributes to the overall structure of your project. Now, we also added support for dependency trees, so you can better understand dependencies of your project, and namely how one dependency can bring another and what depends on what. And we have this super cool, I think, feature, which is the class level SBOM. And by using this flag, enable SBOM equals class level, you can produce a very detailed SBOM that goes all the way down to modules and fields and classes of your application. So you can have extremely detailed information, very fine-grained, and you can better understand what is actually included in your application. And then if you know that some specific class or part of your application can be problematic, or maybe there is a specific vulnerability in one of your dependencies, you can better understand if your application is actually vulnerable, so whether or not it is using that part of the dependency. And this way you can also reduce the number of false positives, because it could be the case that you are using a dependency that has been reported to be vulnerable, but you maybe are not using that part of that dependency, so you can reduce the number of false positives. And better yet, if you are using GitHub Actions to build and host your projects on GitHub, it also has an integration with our GitHub Action. So then you can use GitHub's APIs to analyze your dependencies and track vulnerabilities on GitHub.
And the big difference here is that in Maven and Graal world, you can do SBOMs already, but they just work on the component jar level, right? So if you, for example, accidentally include a test dependency and deploy that, and then maybe there's something being pulled in which is vulnerable, and you're actually not deploying it, then it may still be in your SBOM that you generated with Maven and Graal, because they don't see this. But with native image, you can create an SBOM based on the static analysis, and that is far more accurate. And even though the tooling right now does not support class level, maybe in the future, vulnerability scanners can identify vulnerabilities per method, for example, and then can say your native image is secure because the vulnerable method is not even in your native image, right? So that's something really cool that we can do with native image. And yeah, I see a couple of comments in the chat. So Dan Vega.
Oh, hi, Dan. Good to see you.
Dan.
We have some cool updates for Sprint projects, so stay tuned. I think you'll be happy to see them.
Yeah, recycle, use Java, and take care of the earth. Yes, and not just garbage collection is great in Java, but also native image and GraalVM. So that's very good. Yeah, and Johan is also looking forward to the improved SBOM support. Great.
Perfect. Okay, and one more thing that we want to talk about in this release is our build report. So again, this has been available in native image for a while, but we have added a few new features and improvements to our build reports. So in general, our build reports is something that you can generate alongside your build. As you're building your application, you can pass a flag to emit build report, and it will produce this nice HTML report that gives information about your build. So how long it lasted, how many resources it took, and then it can deep dive into the actual native executable. So you can explore your code area, you can explore your image heap, see what makes up your application. Maybe it's too large, so you will be able to see what contributes to the size of your application. And among other things, it also includes support for SBOM. So that's yet another way to see the SBOM of your application. And you can even visualize based on the profile information how much time your application spends in which methods. And I think this sets me up nicely to transition into demos, because I actually want to show you some of that SBOM features and build reports. So let me see if I can get this on here. So I have my cloud instance running, and apparently I even had my application still running. So I have a Spring Boot application, and we will take a look at it in a second. But first, let me recompile it. So for that, I will compile it with Maven P native, and I have a specific profile for my SBOM features where I can pass my build args. And let's just compile it. Native compile. And I want to point out that Fabio made me change my JDK installation 5 minutes before the live stream. So this is a very fresh setup. So if something goes wrong, you can tell that we are living on the edge. We are running things live, and we are using always the latest versions. So this is running on the actual GraalVM for JDK 24 production released build that you can also yourself get from SDK Man. So as our application compiles, we can take a look what's inside. This is my normal Spring app with a couple of classes that expose different endpoints. And then in terms of the project structure, here is the interesting part for me. So this is the native Maven plugin. That's why we're always telling you, please use our plugins, and then multiple frameworks are nice enough to include this by default when you enable native image Spring Boot. And the reason why we recommend using those plugins is because it's a nice unified interface to native image where you can configure all the things you like. For example, in my case, I'm giving a specific name for the native executable, so I know that that's the one compiled with SBOM. And then I'm saying that I want my SBOM to be both embedded in the native executable, but also available as a ClassPath resource. And I'm also emitting my build report so we can take a look at what's inside my native executable. And then as we are talking about it, our application has compiled already, and it's compiled in 1 minute, 6 seconds. And I know that this is another thing people often ask us about compilation times and whether we can make them faster. So I think this is already pretty fast and nice for a fully fledged web Spring application. I'm not even using quick build mode or any other tricks. So this is production grade Spring application compiled in 1 minute, which I think is pretty nice. So let's run the application, and it's target demo SBOM, and it starts and it runs nicely in 61 milliseconds. And then if our, okay, I need another browser tab because I have my streaming. Let me get it. Got it. So if our port mapping persisted, we will be able to get a response, and we got a response from our application. Now, we can do a number of things here with our application, but the first thing that I want to do is I want to scan my application to see if there might be any vulnerabilities inside this application, and because it is compiled with SBOM, I can actually do so. So for that, I would need to do native image inspect --SBOM. So this will extract my SBOM. Then I'm passing as an argument my freshly compiled application, demo SBOM, and I want to feed it into Drive directly, which is my vulnerability scanner. You can use any one of your choice. This just happens to be mine. And we can see that it scanned my application. It has detected 47 packages there, which is quite a bit. So this is, a normal web app. And it says that there are no vulnerabilities found. So this is nice, and I think it's a nice feedback to have that there are no vulnerabilities in our application. So one more thing that I can do here is if I want to somehow further explore this application, maybe I want to see that SBOM file for myself. One thing that I can do is I can do SBOM, and then I can print that output to a file. So let's say we want to do output JSON. And this will extract that file for me somewhere here. And I just happen to have it open. Oh, I don't. Too bad. Okay, let me open it again. So this is my output JSON. And then I can analyze it and see what's inside. And one thing that I like, we mentioned dependencies when we were talking about features in this release. So one thing that I really like here is I can understand that, for example, Spring Web MVC is something that I'm using, and that it in turn depends on things like Spring Core, Spring Web, some of the core Spring libraries. So I can better understand the dependencies in my application and also what is connecting to what and what is pulling in what. So this is nice. And then lastly, there are multiple ways to work with those SBOM, but one more thing that you can do is I have built my application with Spring Actuator. So I can then again run it, and I can go to the endpoint and actuator, and Spring knows about the SBOM application in my native executable, and it can correctly show it here under SBOM native image. So this is a nice integration, and clearly this is not something you can want to expose to the outside world, but maybe for your internal use, or if your security team comes to you and wants to scan your deployments, you can point them to endpoint and know what is actually running in your deployment and know that your applications are still safe and secure.
Note that in this demo, Alina used ClassPath and embed. Embed means put the SBOM in the executable so that security scanners like Graal can find them. And ClassPath puts them on the Java class path, which is where they're then detected by Spring Boot actuators. right? So you don't need to use both all the time. You can decide. There's even another option, export, which will cause the build to export the SBOM file as a JSON. So you can choose whether you want to build a native executable and have the SBOM separate, whether to include it in the binary so that you can use security scanners, or that you want to put it on the class path for example, Spring Boot actuators.
Thanks, Fabio. And I think this looks good and fun, so it all works. Our native executable is secure. So if I had something like that running in production, I would be happy, but that makes for a like slightly less exciting demo. I think it would be nice if we actually found something vulnerable in our app.
Yeah, well, let's see if it works, right?
Yeah, maybe we just like hard-coded, 0 vulnerabilities, and that's it. So for that, we can... Yeah.
And somewhat you would expect that you don't get any vulnerabilities for a fairly new Spring Boot project, right? So
yes, as Josh says, it's a demo. Of course, it works, right? So, so let's go into another destination that has an exciting name: native Spring Boot vulnerable. And there I can use pretty much the same scanning command, not this one. Actually, let's do this one. So there I also have my application compiled, and I have yet another version of it with a different set of dependencies, and it has, again, the exciting name vulnerable. So if I scan this one, and I need to, once again, put it into Graal, so now it complains that in that demo, I'm using JSON as a dependency. So it's a very similar project. I just added JSON, and I made sure my application is actually using it so that the dependency is not stripped away. But now by scanning that one, we can tell that there is this dependency and there are 2 high severity vulnerabilities in it. So maybe we want to go ahead and fix it.
Meanwhile, there's a couple of questions coming up.
Okay.
So Rotinato asks, did I understand correctly that this SBOM report and native image only includes dependencies when code of the dependencies is used reachable from my program? Yes, that's correct. Yes. So if native image, for example, deems one of your dependencies to be not reachable, then it will not be included in the report. Which means if you have messed up your POM configuration, for example, native image can fix that for you, right? Can fix it for you.
But I think it's actually nice to have this fine granularity, right? So if you're pulling in a number of things, but you're not actually using them, and native image can strip them away, I think this greatly reduces the number of false positive, because if you are not using those things, we will not include them, right? So you don't need to be worried if you're not actually using them.
Yes, and then there's another question from Vasily. Is SBOM serialized and executable somehow, or I calculate by native image inspector? So I guess the question is, like, how do we do this? If it depends, as usual. So if you put it on the class path, it is represented as a Java resource in the image, and I think that's represented as a Java byte array. If it's in the data section embedded, then it is actually zipped. So it's well, we can do compression for Java resources, but the embed always zips the file, zips the SBOM inside the executable to make it really, really small. And of course, if you export it, then it's not compressed at all, and you can just read the file. Okay, and apparently Rotinata is quite happy with the answer. That's good.
Perfect.
Yes.
Perfect.
Let's continue.
Yeah, and along with this build, we also generated our build report. Where is it? Here. So let's take a look inside. Okay, why do you not want to open? Yeah, that's the one. So again, in this build report, you can see over the time, maybe you want to compare actually them over the time, you can get info such as which GraalVM version was used, how many resources were used, what is the result of the analysis, what we detected in your application, namely in the code area, and what is included in the image heap. And then here you can drill down. So here we are looking at the methods in my application, and maybe I want to choose the ones that are actually IoT compiled. And here I can go down, let's say, into Spring Framework and see down, by going down, let's say, to actuate, how many methods are included by there and what actually makes up the methods in my native executable. So I can either view it here, or I can switch to a histogram and see how all the different methods and packages contribute to my application. So this is the code view, and similarly, we have a view for image heap, where you can again see what kind of objects make up your image heap. And then in resources, you can analyze a similar thing. You can see what contributes to your application and its size, namely, And for example, for injected resources, those might be the things coming from your framework. And again, this was the application built with SBOM support. So this is yet another way to view and then maybe export and view in more detail your SBOM. You can see what's in our application, all the dependencies and versions. And here we see information that we have collected during a PGO profiling run, where we see as a flame graph all the methods that we observed as we were running that profiling run of native image. And we can see where our application spends more time, either in this view, or we can actually use the search, and then we can want to look for something specific, or let's say all things related to web. So this is also interactive and clickable. So this is another tool that you can use to better understand the context of native image and maybe compare your builds across time. Okay, and I'm slightly going over time for this section, but I want to check super quickly if I can switch to a different cloud instance, because I do want to show that Llama application running, if I can get it to open. Let's try this super quickly. Llama, why not? Oh, right. Demo Llama 3. What? Oh, right. Llama3.java. Okay, so now we are on a different machine and we want to have that LLM inference engine running locally. It's a Java program, but I have it compiled as a native executable. And the way this works, this is a one single Java source file that is my entire engine. And then by having alongside my model, I can actually have fully local LLM inference running without internet access, without connection to anything like OpenAI, Anthropic, whatever you might call. This is running fully locally. And then if I can get it to run, because it is sometimes a tricky one, Llama 3, and I will pick up this specifically AUT version, although they are all natively compiled, but this is with additional optimizations, and pass my model, which in this case will be Llama 3.2, 1 billion parameters, and then maybe I want to chat. So it starts in 0 milliseconds, and then we can ask it something. So we can do maybe hello, and we can ask it, what can you do? And it can do a number of things, such as answer a question, play games with you, translate, proofread, etc. And this is written as a Java project using FFM API and Vector API, and then compiled to a native executable with this insane 0 milliseconds startup. And you can check it out on GitHub by this name, llama3.java, and give it a try. But make sure to compile this native image, because that one gets really fast and really awesome. Okay, I think, Fabio, at this point, we can switch to the languages part, because Fabio also has a plane to catch to go to Vasmayo.
That's right.
Do you want to screen share? Yeah.
Yes, I can try and screen share.
Show on stream. Yeah. Right.
So yeah, there's another blog post on our Medium from Alina about the language, the Graal languages. So there's a lot of cool updates. We won't be able to go through all of them in detail, but as usual, we'd like to cover the most important bits. So in general, there's a couple of changes. For example, with regards to native access, some flags that you just need to set in order to avoid some warnings from the JDK. The Graal languages, they make extensive use of the infrastructure within the JDK because we can use the Graal compiler as a JIT for GraalPy, for GraalJS and whatnot. It needs to have additional permissions. So right now you will need to set a couple of flags to essentially just hide warnings from that you otherwise get from the JDK. So that's not super exciting, but something that we still wanted to point out. We have some features like when you're using context and engine API, they will now close automatically when they're no longer referenced. Typically, we recommend that you close them explicitly, but sometimes users forget. So this is a nice way to make it a bit better. And then we also have a value API to interact with values from guest languages. And we extended the API a little bit with a way to convert buffers and byte arrays. So these are really general updates. But now with regard to GraalPy, we have some cool new announcements. So GraalPy is our Python runtime that you can embed in Java applications, so you can make use of the Python ecosystem in your Java applications and Java projects. And in the last release, we have introduced a Maven plugin that allows you to essentially depend on Python packages from within your Java application. And in this release, we are also shipping a Graal plugin. And Graal is a bit more flexible than what Maven can do. So what's really cool about the plugin is that you add it to your configuration. And then you can say GraalPy packages, and here's my set of Python dependencies. And the plugin will automatically inject all the other dependencies that you need. So you don't need to depend on anything else. And the version that you will pick up will be the version of the plugin in this release. So this is really all you need to do to get access to GraalPy, and I think that's a really cool thing that the team has put together. There's also lots of cool details also coming in the next couple of releases where we help you to freeze, for example, specific Python versions of your packages, because in Java, every version is fixed when you build your application. In Python, that's not the case, but we want to give you the same experience that you know from Java for Python, and make it as easy as possible for you to play around with Python and use Python in your Java application. So there's a lot to talk about in this. However, there's also a problem with the languages in general, because some languages, they are not really multi-threaded, but Java is multi-threaded, right? So we want to use Python, but we also want to use it in Java, and what do we do when we mix them, right? So that is something that we've also been working on. So we have some cool news how Python can be scaled across Java threads. And if you know a little bit about Python, you may know that a lot of Python code actually uses native code under the hood. So that means shared libraries that you need to load at runtime. And you may also know that you can't easily load a shared library multiple times in the same process. But with our new option, isolate native modules, we can actually do just that. So what you can do is you can create n instances of GraalPy and load the same native extension in each of these contexts separately from each other. And that allows you to scale Python code across multiple Java spreads better. Right? Because usually if you just have one context to load one native extension, one instance of the native extension, all your threads will need to talk to that one context, but now you can parallelize. So in this little application here, we are using Pandas, which uses native extensions under the hood to analyze a large CSV file inside a Micronaut application. And this ran on Tim's computer. Tim is the Graal Python lead, and his computer happens to have, I think, 6 performance cores or something like that. So considering that 1 or 2 of his cores needs to also send requests to the service, you can see that this is nicely scaling from 180 seconds total runtime to something like just below 90 seconds, so cutting the time in half, while also providing 5 concurrent clients with 50 requests, essentially, 50 calculations. I've been a bit fast. Are there any?
No, all cool. One more thing that I wanted to add about the Gradle plugin. So I like, So I like there that you can specify which packages you want to use for GraalPy from your Gradle or Maven build file, because normally if you ever tried this kind of polyglot programming, one big issue there is how you build such a project and how you bridge this gap between let's say Java packages and Python packages, how you bring all of this together. So for me, working with Java, if I can specify what I need from Python exactly from my Java build file, this is amazing, because I don't need to deal with the messy configuration. I can just work with my normal build files. So this is really convenient.
Yeah, and if you want to learn more, even how you use it in Maven, just go through the GraalPy website. It's up on the GraalVM website. You can find it there under GraalPy, and it tells you what Maven dependencies you need, what Gradle dependencies you need, how you can get started and start evaluating Python code, and how you can add dependencies, Python dependencies to your Java application. And it's really, really simple. We have a bunch of guides showing you how to use GraalPy in Spring Boot, showing you how to use GraalPy as a replacement for Jython or in Micronaut, how to do debugging and all kinds of stuff. So take a look and let us know if you have any questions, if you have any suggestions for making it better. Okay, so in addition to the scaling for native extensions, we also have a really cool integration that makes the communication between Java and Python better. So the problem typically is that if you want to pass a data structure from Java to Python, the data is laid out slightly differently. Java is in control of how the data is laid out, and Python also wants to be in control of how the data is laid out. So in the worst case, if you're passing a really big, let's say, data frame object or something like that from Java to Python, you eventually need to copy all that data from the Java layout into the Python layout, only to pass it to pandas, for example, and then get the result back. And even though with polyglot programming and embeddings, you can get the time down, the communication time and the overhead between Java and Python, you can get it really good down, because you have no network connection, nothing between Java and Python, and that you otherwise would have in a microservice setup. But even with an embedding like this, and where the communication is really efficient, you still need to copy the data. So in this release, we have another experimental feature which uses Apache Arrow, and Apache Arrow is a shared data representation initiative, and there are implementations in both Python and Java. So, and the new integration allows you to essentially allocate a Java object using the Apache Arrow implementation for Java, and then you pass that to Python and then run it through pandas without any copying at all. And that saves you even more time. And that's why the second graph is so much shorter, because as you can imagine, like most of the time spent here is in copying and not actually processing your data. Whereas if you don't need to copy it, then you are really, really fast. So we have a demo for this on our demo repository. Link is in here. You can check it out and give this a try. And I think, yeah, we made a lot of cool progress in this release for GraalPy, and we can't wait to share what's next. So stay tuned for more updates. Right, one more thing that I almost forgot is we also improved the interoperability between Java and Python. So now, for example, Java maps or lists appear as Python dicts and lists. And you can also configure the way back how a Python object is represented in Java. And so that's kind of nice. Okay, on to the next batch of languages. So for JavaScript and WebAssembly, we have implemented a bunch of proposals. So for example, for JavaScript, there's now a bunch of new ECMAScript proposals supported by GraalJS that you can use. But the one proposal that I like the most and the coolest feature in this release, I think, is the WebAssembly as module integration. It's a mouthful, but all it really allows you to do is you can import WASM modules with the import statement. So, and why is that cool? Well, we already showed you a demo some time ago where you can embed Rust code in a Spring Boot or Micronaut application for image processing. But you somehow need to marry JavaScript bindings with the WebAssembly module. And typically, the compiler toolchains for compiling Rust, Go, or C++ to WebAssembly give you a binding. And these bindings, they use this module integration. Here's the binding for the demo, for our Photon demo, the one that I was just talking about. And this one loads the WASM module, loads the JavaScript binding, and then it imports the essentially initialization function, and it marries the two and starts the binding. So before, until this release, you couldn't really use this, but now you can just use this in GraalJS and then use the JavaScript bindings to do high-level interactions between Java and WebAssembly. It's kind of crazy, but it works. And so far, WebAssembly doesn't really have a good concept for exchanging data structures apart from the JavaScript bindings. But that's not a problem because we have a JavaScript runtime, and you can use just that. So check out the demo that we have in the demo repository for Photon, and we keep improving it as we go to make it even simpler and more powerful. Yeah, we also upgraded our Node.js runtime to 22, and there's a bunch of more updates. Okay, now on to Espresso, and I'm trying to be a bit quicker now because I still want to do a demo, and we only have so much time left, right? So in Espresso, just as a reminder, that's our Java runtime built on Truffle. So it's a Java built in Truffle, and we haven't really talked about it much in the last couple of releases. But in this release, we have a really cool, exciting new feature that I actually want to demo. So Espresso has a new continuation API that, unlike the API for continuations in the JDK, is not internal, so you can use this. But what's really cool about it is that it can also be serialized to disk. So that means it's not a one-shot continuation. It can actually be used as a multi-shot continuation. And we have listed here a couple of use cases where this might actually be useful. So for example, if you have a service running that talks to some other service and waits for a response, you can pause the waiting service and save the machine resources, the computing time. And then when the result comes back, you can resume the Java application. And because this is persisted and serialized to disk, it doesn't necessarily need to be on the same machine. So that means I can run a Java application, pause it in the middle of the execution, and then give this to Alina and continue the application on Alina's computer, right? So that sounds a bit crazy, but well, let me show you what that looks like.
I love this API. I think this is pretty cool. And all the use cases we listed, I think many people will find something interesting for them among those use cases. So I think this is really cool.
Yeah, so if you click on serialization example, here is an example that we have on our website, and I copied this into IntelliJ. So this is the persistent app in IntelliJ. I'm running this on Espresso. So Espresso is my JDK. We can take a look here, Espresso 24.2. And I'm using it here. And that's the persistent app, which is a continuation entry point, right? So what this application can do, it's really simple. It's just to illustrate how this works, right? So every time I run the program, it increments a counter and it prints out the new value before quitting. So if we take a look at the application, here's a counter field, and here's the start function that we need to implement, and here's a while true loop. So IntelliJ thinks, well, we cannot exit this loop ever without an exception because it doesn't know that this is a continuation demo. Right, so we increment the counter, we print the value, and then we can do more work. We can do more work right after the printing. And then we call this suspend from the suspend capability. This is where the application essentially suspends and exits. And then after this, we can do something else. But because we don't do anything else here in this demo, we will go back in the loop, we will increment the counter, and we will print. Right, so let me run this. And the first time I run it, it runs on Espresso, right? And it uses the experimental option continuum for our new continuation API. So now the counter is at 1, and then the process finished, right? So this is a normal Java application that I wrote, or that we wrote, and I can run it here. And if I run it again, now the counter is 2, right? So that's kind of crazy because like the application continued right after this inside the loop, and then it runs again. So I can run it a bunch of times, and it will just continue. So now you may be wondering, where's this stored and how can I control it? Well, we allow you to implement your own serialization. This is actually a serializable. So in this example, I've been using a simple, simple serializer, an object input stream, and an object output stream from the JDK. They're really simple. You can use them. And by default, the demo actually outputs a file. I forgot, here's the name, state serialize bin. You can also use other serialization libraries and frameworks like Creo, but for this demo, I didn't want to set it up. We don't really need it right now, but it's even more efficient for serialization if you need to serialize even more. Here, we just need to serialize a simple counter. So if we look at on disk, there's now a file called state serial bin, because that's the name we gave here. That's the default name for the file. And this file essentially contains everything Espresso needs to know to continue the execution of your program. So, and if you look at this is a 1.3K file. It's really, really small. If I just give this file and the application to Alina, she would be able to continue executing the demo on her computer. And I think this is really cool illustration of what you can do with Espresso. So now this is 1456, and if I run this again, it's now 1457. So if I ls the file, see, it has been updated by the program. And if I remove the file and run the demo again, we start at 1 again, right? So that's how this works. Okay. Let's get back to the stream. Wolfgang says, Espresso always fits.
Yeah.
Yes.
All good. Many excited comments.
Yes. Espresso always fits in the morning, in the afternoon, all day long. Okay, so let's talk about the last 2 big updates. So there's a couple of updates for Truffle Ruby. We have upgraded the Ruby version to 3.3.5, and for the first time, we're using Panama for the C extension support. So Panama provides even better performance, and we already see this in our languages. So for example, C extensions in Ruby, like SQLite, Trilogy, and JSON, we already see 2x to 3x performance improvements just because of Panama. So this is good news for everyone who is excited about Panama, but also everyone who's using Truffle Ruby. And I expect in the future we'll have more C extension backends, C native backends, and languages adopt Panama. Truffle Ruby just happens to be the first.
So Fabio, before we jump into the Bytecode DSL, Cedric is asking or maybe wondering about serializing to Kafka streams.
Good question. I guess you could try that out.
Let us know.
Yeah, Cedric, give this a try and let us know if it works. And if it doesn't,
you know where to report to the Espresso team.
Yes. So I actually had a chat with the team lead of Espresso, and he told me that one of the things that they're considering is using the continuation API to do virtual thread support in Espresso, which would mean you could serialize virtual threads and continue them on another machine, which is kind of crazy. So we will have more updates on this in the future.
No, but honestly, I think this is a very cool API. We have plenty of plans for it, and we hope the community will be just as excited about it.
Yes. Okay, on to the last section, because we are already on the top of the hour, but to be fair, we also started 5 minutes later. So in the Truffle framework, that's our framework that we use to implement all our Graal languages. We also have exciting news. We've been doing a lot of research and work on something that we call Bytecode DSL. And this is the first time Bytecode DSL actually ships in a GraalVM release. So it's not been used in one of the languages yet, and we're working on that right now. We want GraalPy to use it first. But you can already use it yourself. We already have implementations for simple language and a bunch of other language implementations for experimentation. But what's really cool is that in the past, Truffle started out as a pure AST interpreter framework. So all the languages would be implemented as an AST interpreter. And we've learned that ASTs can be a bit bigger in size and also not as performant as bytecode interpreters. So And so we are shifting towards bytecode interpreters because they're more memory efficient and they're faster in terms of interpreter speed, while yielding the same peak performance. And the problem now is that bytecode interpreters, getting them right and letting them do the right thing in a performant way on the JVM is rather complicated. So the Bytecode DSL allows language implementers to build a bytecode interpreter without having to write one. They just have to provide operations, which is essentially what does your language do? How are the semantics of your languages implemented? And you need to provide some sort of parser infrastructure in front of this and emit instructions. So here is just a simple visualization of something that looks like Python. You would turn this into an AST-like builder, and this thing will emit bytecode. And we will take care, or the Truffle framework will turn this into bytecode interpreter, which is really efficient and runs your language. So clearly, this is a feature for language implementers and tool implementers. And we already have an implementation for GraalPy that we are about to merge. And hopefully soon we can make it a default, which means GraalPy users will see even better interpreter performance and less memory consumption. And the goal is to expand this to all of our languages and make them more efficient and faster. Okay.
All good.
What we're doing in the chat.
All good.
Yeah, as usual, there's a couple of community updates. We have demos also how to do visualizations, SVG charts, for example, using Python libraries and Micronaut and Spring. GraalPy and GraalVM, they were featured in InfoQ's Java 2024 trend report. That's pretty cool. Tim and I did a talk at JFocus where we talked a bit more about embedding Python code in Java applications using GraalPy. And Christian Hummer had a chat with Adam Bean on the Airheads podcast, and I believe they didn't finish everything they wanted to talk about in the first session. So Christian told me he actually was invited another time to talk with Adam. I'm not sure whether that's published yet, but
I don't think it's been, but yeah, there are such plans.
Yeah, they definitely have some fun talking about Truffle and all of our Graal languages. Okay, and that brings us to the end. Are there more questions in the chat?
Not yet. We can give people another minute. As they are coming up with questions, we just want to once again encourage you to go to GraalVM.org and download GraalVM, or use SDK Man and just pull the latest GraalVM for JDK 24 version. Try running your applications, give us feedback, namely give us feedback on some of the experimental things that we talked about. So SkipFlow for smaller native executables, the agent support and which agents you want to see supported in native image. Also, please give us feedback on those more production-grade features, such as SBOM support will be very interesting, and performance optimizations, and the support that we have for FFM and Vector API as we keep working on those. And also go ahead and try other languages and the language demos that Fabio have showed you.
Yes, and in the next couple of months, we are super excited. Well, actually, on Friday, my colleague Patrick and I will be at WASM.io. We have some cool news that are coming in a 25 EA build of GraalVM. And then the next time Alina and I meet with you guys, hopefully, here on YouTube and talk about the next release, we'll be talking about the next LTS release of GraalVM, which is super exciting. Right, so looking forward to sharing some news very soon, some more news, and hopefully for today we covered everything in this release. Get in touch if you have any questions and if you have any use cases you'd like to discuss with us. And otherwise, happy hacking.
Yes, thank you all. And you can always find us on social media. You can join our community Slack. You can talk to us on GitHub, whatever platform works. We love talking to you. Okay, I think we are good. We can wrap it up. And if you have any questions that we haven't answered, or if you come up with something new, just join us on social, on Slack, and we'll be happy to answer those. Thank you all and have a nice rest of your day.
Bye-bye.